Hello everyone. My name is Havish Madhupati and I would like to warmly welcome you to this course R for Absolute Beginners. Now there are a few reasons why everybody is super scared when it comes to working with R. One of the reasons is that they feel that the course is only for data scientists, which is true. R is meant primarily as a data science tool, but it is not just data scientists who are working on it nowadays. Another fear that people have is that will we have to learn coding and programming? Yes, you will have to learn how to code, but at the same time, R is a tool aimed more at getting business results. It is not so much about writing the code, but about generating insight and knowledge. So I would say that the process that we follow in R is to give raw data as an input, and we end up getting insights and knowledge as an output. Should you learn R? An absolute 100%. I feel that everybody needs to have at least a little bit of understanding of how data science works, even if your job profile doesn't require you to work a lot on it. Now, R is a very, very large field, which means that no single course can help you master it. You would find people who have spent years and years working on R, and because it is a dynamic area, you will see that more and more developments happen in it, which means that new capabilities are created, new libraries are added, and people figure out better ways of doing existing projects. Now, if you look at the process that we are following, in this course, we would be looking at a couple of different things. So in this course, we would broadly look at how to tidy data, which is just a fancy word for saying that we will clean data. We will learn how to transform data, which means that we want to narrow down to the observations that interest us. Now, tidying and transforming together are called data wrangling. After this, we have data visualization, which I'm sure that all of you would have heard of. Visualization is a fundamental human activity, which means that we do it everywhere. Whether we have Excel, Power BI, Tableau, or maybe just a pen and paper. People like to create visuals and people like to present stories using visuals. We will learn how to create models which are just complementary to visuals. Models are fundamentally mathematical or computational tools, which means that they scale very well. So for example, if you're building a model for a small company which only has 500 customers today, and then after a few years they scale up to 50,000 customers, a good model should automatically be able to scale accordingly. We will also talk a little bit about communication, which means that no matter how good you are with the coding, it is very important to be able to communicate it properly to the different stakeholders, especially because the stakeholder might not come from a programming background and they might not understand what you have done from a pure code perspective. Now, do keep in mind that for a data science project, we typically follow a thumb rule where we say that 80-20. The 80% here refers to the tools that typically in a project you need to work on, and the balanced 20% are the tools that you gain with experience, which means that 80% you can learn from a book or from a course like this that will help you with most of your work. But to put those final touches to the project, you will need to learn the 20% as well. Now in this course, we will be focusing on all these different areas: data wrangling, data visualization, creating models, and then communicating, as well as a little bit of programming. Now, the first thing to understand is R the only tool out there? Absolutely not. So we have tools like Python, we have languages like Python and also Julia. Python, Julia and R are three of the biggest languages when it comes to data science. But R is a specialist when it comes to data science. So it's the most flexible language. Are there any prerequisites to be able to do this course? Not really. Having a little bit of background in coding will help you, but it is by no means a prerequisite for this course. What do we need to install? So there are two things that we would need to install. First, you will have to go to CRAN. CRAN stands for the Comprehensive R Archive Network. And from here, you can simply download R for Windows, Mac or Linux. Now when I click on this, you notice that it's a very small file, only 84 MB. Now I already have it installed on my computer, so I'll not do it again. Once you have installed R, you have to make sure that you will also have to install an integrated development environment, what we call an IDE. So an IDE is nothing, it's a development environment which allows you to do software development. And the IDE that we use for R, the most popular one, is called R Studio. Now R is free, that means the language as such is free. But R Studio is available in different packages. So if you look at the product portfolio, we have R Studio Server, R packages as well as Shiny Server. And if I look at R Studio, you would see that we have R Studio Desktop and R Studio Server. And if you keep on scrolling, you will notice we have an open source edition, which is the free one, the one that we will be working on. And we also have a pro version that gives you certain more capabilities. This costs an organization $1,000 per year. Similarly, you have R Studio Server, which we would not really need at the moment, but it's good to know that R Studio Server also allows you to download both an open source as well as a pro edition. So very simple, you can simply go to rstudio.com and download R Studio Desktop. Once you have done these two things, you will open R Studio and it will look like this. As you can see, it's a fairly clean interface. Does it seem a little complicated? If you have done absolutely no programming earlier, yes, it does. It does seem a little complicated in the beginning. But do remember that R is meant not just for data scientists who come from a statistical and a mathematical background. R is also being used by non-programmers and non-statisticians, which means that the tool is very, very user-friendly. Yes, it's very easy to pick up, but very difficult to master. There are hundreds of small things in R Studio, but for a beginner, you would not really find it very difficult. Now, one thing we want to do here is to install what we call a package. So let me come back to my notepad. Let's see what is a package. A package, simply put, is simply a collection of functions, data, and documentation. And what does it allow you to do? It extends the capabilities of R. which means that there are some base packages which are already installed in R, and on top of that, you can install even more packages. How many packages are available? So if you go to R packages, you will have CRAN packages by name, and these are thousands and thousands of packages that you would find. And it almost seems crazy that so much is available. You will have things for proper machine learning, AI, text mining, sentiment analysis, statistics, forecasting, graphics, interfacing with different platforms. Literally anything and everything that you would expect is available here. Let's take an example. One of the most popular packages that we work on when we use R is called ggplot. And if I click on it, you can see that it gives me a little bit of idea as to when was it created, when was it published, what is the license, what is the URL, and things like that. Do we need to download a package from here? Absolutely not. We can download a package directly in RStudio. So what do we do? Let me click on new file and create a new R script. This is an untitled one script, and all we need to do now is to write install.packages. Now if you notice carefully, the moment I write install, IntelliSense works. So in programming, IntelliSense is very important, and IntelliSense simply means that it's an autocomplete, or what we call code completion. It works on nearly all integrated development environments, and it's a very, very important part of programming, because nobody can theoretically remember everything that is there to be remembered in a programming language. So the moment I start typing, it automatically tells me the options that are available. So in install.packages, what do we want to install? We will install something called tidyverse. TIDYVERSE. Now, the tidyverse package is one of the most common packages that we use in R, and just one single line of code is required. When we click on run, a few things happen. On the right, you notice that install.packages tidyverse is in the history, and then in the console window, you will see that it says that the tidyverse package has been successfully unpacked and downloaded. Now this means that you have simply installed it, but then how do you upload it? How do I make it a part of my current R workbook so that I can use the different capabilities in it? For this, we will write library tidyverse. This means now we are able to use the functions, objects, and the help files in a package once we have loaded it. Again, when I click on run, it says library tidyverse, and it has been loaded properly. Alright, now let's see. What all is available in tidyverse? If you notice, these are the packages that have been attached. We have ggplot, tibble, tidy R, read R, PO_RR, DP LYR, string R, and forecasts. Now these are some of the most common packages that we require. Now this is what we call the core. We call this in tidyverse, we call this the core, because these are some of the most important packages that everybody would need to work with. But what about other packages? Now in addition to tidyverse, there are, like you saw earlier, thousands of packages available. And it's not that some of them are good and some of them are bad. In fact, a lot of these are interrelated. So it's not that packages are independent of each other. Does anybody remember every single package available? Absolutely not. The more you work with R, the more and more you get the chance to work with R packages. But since there are so many of them, believe me, even in a lifetime, nobody would theoretically be able to work on every single package. So the challenge is not to learn more packages, but the challenge is to identify the ones that are important to you and understand them very well and become proficient at them. I will also be using 3 different packages now. So we will again click on install packages and we can install different packages in one go. One is NYC Flights 13. Then we have Gapminder. And finally we have Lahman, Lahman. We will again click on run. And as you can see, it says that the Gapminder is not writable. That's all right. Let's only focus on NYC Flights for now. I think that's the only one that we require. So as you can see, the NYC Flights package has been successfully unpacked, and now if I want to load it, we can simply say library and NYC Flights 13. We click on run, and as you can see, we have loaded it. Alright. Now how does our code look? So far we have only installed packages and we have used library to load it. Let's take some simple examples. If I write 1 plus 2, a basic arithmetic operation, and I click on run, it gives me 3 as a result in the console window at the bottom. Let me also clear everything. So you can click on this button to clear the entire window. Let me click on 1 plus 2 once again, and you get 3 as a result. If you wanted to, you could have written it directly in the console window as well, and the result will come here. Alright, so we are getting the hang of how this works, and let's now look at something more detailed. We would want to look at how, when we are working on R, we want to focus on data exploration. So data exploration basically means that we are looking at the data, we are generating hypotheses, and we are testing them and repeating them again and again. This is also part of what we call EDA, which is exploratory data analysis. We will look at this topic in the next lecture.